So welcome students. In this video, let us look at the topic of pedal triangle. So what is the pedal triangle for a given triangle? The triangle formed from the foot of the perpendiculars from the vertex onto the sides is called a pedal triangle. Is you draw the altitude from A onto BC, let the foot of the perpendicular be D. You draw the altitude from B onto AC, let the foot of the perpendicular be E, and let the foot of the perpendicular from C onto AB be F. The triangle DEF is called the pedal triangle of triangle ABC. So now, what are the things that you need to know about the pedal triangle? So the first thing that you need to understand about the pedal triangle is the orthocenter of triangle ABC, which is equal to H, the point of intersection of the altitudes. The orthocenter of the triangle ABC is nothing but the incenter of triangle DEF. Orthocenter of triangle ABC will be same as the incenter of the pedal triangle. And the second point which you need to understand is that the circumradius of the pedal triangle, the circumradius of pedal triangle is equal to the circumradius of triangle ABC by 2. The circumradius of triangle ABC divided by 2. That is, the circumradius of the pedal triangle will be exactly half of that of the circumradius of the original triangle. So these are the two things that you need to understand. So how do I get these two properties? This is what we're going to deal in this video. So to prove that H is the incenter of the pedal triangle, what I just need to prove is, I need to prove that this line DA is the angle bisector of angle D. That means I need to prove that this angle is equal to this angle. So if I can prove that the altitude of triangle ABC is the angle bisector of triangle DEF, then the point of intersection of altitudes of triangle ABC, which is the orthocenter, will be same as the point of intersection of the angle bisectors of triangle DEF, which is the incenter. So my aim is to prove that these two angles are same. So to do that, I'll use the angle properties which I have used in orthocenter. So first, what is this angle? This angle is nothing but, because this angle is 90, this angle is nothing but 90 minus A, right? Next, what is this angle? This angle is also equal to 90 minus A, because this angle is 90, this angle is A, so this angle is 90 minus A. Now, I'll use the first result, which is points B, F, H, D are concyclic. Can I say this? Points B, F, H, D are concyclic because the sum of angle BFH and BDFH is equal to 180 degrees. The angle this plus this angle is equal to 180 degrees. So because angle BFH plus angle BDH is equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees. So angle BFH plus BDH is equal to 180 degrees. Hence, you can draw a circle through these 4 points. You can draw a circle through these 4 points. And once you can draw a circle, so if you take FH as the chord, this chord subtends 90 minus A on the circumference and angle FDH also on the circumference. So angle FDH should be equal to angle FBH, which is equal to 90 minus A. So this angle FDH is equal to 90 minus A. Similarly, can I say that points DCEH are also concyclic? Yes, because this angle plus this angle is equal to 180 degrees. Hence, the sum of opposite angles is 180. Hence, these 4 points are concyclic. That means I can draw a circle through these 4 points also. And draw a circle through those 4 points also. Now, if I take EH as the chord, so EH subtends an angle of 90 minus A on the circumference. So it has to subtend an angle of 90 minus A at D also. So angle HCE is equal to 90 minus A. This implies angle HDE is also equal to 90 minus A. So angle FDH is same as HD. Angle FDH is same as HDE. Hence these two angles are same. Hence AD is the angle bisector. AD is the angle bisector. And this implies H is the incenter of triangle DEF. So that proves the first proposition. So next, let us try to prove the second proposition, that the circumradius of the pedal triangle is half of the circumradius of the original triangle. So to find the circumradius of the pedal triangle, first I'll try to find the side of the pedal triangle. So I'll try to find the side EF. So to find the side EF, I use the cosine rule. So what is EF square? EF square is equal to AF square plus AE square minus 2 times AE times EF times cos of angle between the two sides. And what is AF? AF is nothing but B cos A. From projection rule, it is B cos A. And what is AE? AE is, from projection rule, C cos A. AE is C cos A. So EF square is equal to B square cos square A plus C square cos square A minus 2 times this side into this side BC cos square A times cos A. AF square plus AE square minus 2 times AF times AE times cos A. So that is equal to, so B square cos square A plus B square C square cos square A. So if you take cos square A as common, you get B square plus C square minus 2BC cos A. So what is B square plus C square minus 2BC cos A? That is nothing but the formula for A square. So this implies EF square is equal to A square cos square A, and this implies EF will be equal to A cos A. The length of EF will be equal to A times cos A. Now once you got the length of EF, so what is the circumradius of triangle DEF? That comes from the sine rule. Any side by sine of opposite angle is equal to 2 times the circumradius. So EF by sine of angle EDF is equal to 2 times the circumradius of the pedal triangle. A by sine A is equal to R. This implies what is EF? A cos A by what is sine of, what is angle EDF? We have already seen that this is 90 minus A, this is also equal to 90 minus A. So the sum of these two is 180 minus 2A. That is equal to 2R dash. This implies A cos A divided by sine 180 minus 2A is again sine 2A. That is 2 sine A cos A is equal to 2R dash. So these two gets cancelled. Now A by sine A is nothing but 2R of the original triangle. So 2R by 2 is equal to 2R dash. 2 and 2 gets cancelled. This implies R dash is equal to R by 2. It means the circumradius of the pedal triangle is equal to half of the circumradius of the original triangle.